supporter la croix, ton histoire est une épopée des plus brillants exploits. God keep our land glorious and free. Oh, Canada, we stand on guard for thee. Oh, Canada, we stand on guard for thee.
Welcome to the University of Alberta. My name is Peggy Garrity, and I'm delighted to serve as Chancellor of the University of Alberta and to confer an honorary degree on Dr. Brian Cox at today's ceremony. I'd like to acknowledge that the University of Alberta is located on Treaty 6 territory and the homelands of the Métis. In stating this, we must recognize our responsibility in working in relationship alongside First Nation and Métis people and their communities on our way forward, and in good relations in uplifting the whole people for the next 7 generations and the university for tomorrow. On behalf of the entire university community, I'm delighted to welcome you to this special honorary degree ceremony. This is my first time as Chancellor that I'll confer an honorary degree in front of an audience. So I'd like to think this is good practice for the Convocation events that will be starting next week. It's an exciting day for all of us, and I'd like to thank all of you for being here today to join us in this very special celebration. Today we'll hear from Kate Chisholm, Chair of our Board of Governors, and our University President and Vice Chancellor, Bill Flanagan. Distinguished guests on our stage also include a number of guests, including members of our Academy. And I know we're all looking forward to hearing from Dr. Cox following the conferral of his honorary degree, Honorary Doctorate of Science, our university's highest honor. An honorary degree recognizes inspiring role models and leaders, celebrating extraordinary achievements or remarkable service to our society. And I'm so proud to be able to celebrate your honorary degree today. As a grandmother of 2 amazing young women, we shared watching one of Brian's videos on the weekend, and what I most want to say is thank you. Thank you for making science understandable and fun. Thank you for inspiring countless young people and spurring their curiosity to understand more about the world around us. Dr. Cox, we are here to welcome you to our University of Alberta family, and I hope that you and all of us enjoy the day. I'd like to start by inviting greetings from Kate Chisholm, Chair of our Board of Governors.
Eminent Chancellor Garrity, President Flanagan, distinguished guests, and friends of the university community. I'm very pleased to be here today to bring greetings on behalf of the Board of Governors as we celebrate the absolutely remarkable achievements of Dr. Brian Cox. Dr. Cox is a science communicator, author, corporate and public speaker. He is a perfect example of the kind of citizen that brings leadership, knowledge, and understanding to the society in which we live. Competent, empowering, giving, and engaged in the challenges and opportunities of both today and tomorrow. It's my honor to welcome you to this special event on behalf of the Board of Governors and to welcome Dr. Cox into the U of A family.
And now I'd like to welcome President and Vice Chancellor Bill Flanagan to bring his remarks.
Thank you, Chancellor Garrity, Board Chair Chisholm, honored guests, colleagues, and friends. Today's special conferral ceremony launches the University of Alberta's annual spring convocation season. After 2 years of virtual ceremonies, we can now come back together in person to celebrate the accomplishments of the class of 2022. And we begin those celebrations today by honoring an extraordinary individual. It is the University of Alberta's tradition to grant honorary degrees at each convocation ceremony to individuals who exemplify the spirit and vision of our university. Individuals who can inspire and guide us as we strive to make our best contributions to society. Individuals whose commitment to excellence, the pursuit of truth, and the public good are unparalleled. And nothing better could describe Brian Cox, and we are honored to welcome him today into the University of Alberta's community. Dr. Cox, I hope that ours will be a community in which you will always feel welcome. The University of Alberta is a place where we encourage our students to ask big questions, spurred forward by our profound responsibility to seek truth, solve problems, and shape a future unhampered by fixed tradition. This commitment to seeking the truth has never been more important than today. Every day we are confronted with false information, conspiracy theories and thinking, and distrust of public institutions. People struggle to get outside of their echo chambers and question their own truths and assumptions, all of which drives wedges between us, making it so much more difficult to work together to solve critical issues. And there are so many critical issues to solve: climate change, COVID, energy security, food security, and so much more. There are technologies to be harnessed for the public good. And to solve our challenges and harness those technologies, scientific literacy is essential, but not just for scientists, for all of us. We need the tools to distinguish between scientific fact and fiction. We need to understand the fundamental nature of our world if we want to understand our place in it and our capacity to shape it. As you have said, planet Earth, this place where we live, is a beautiful and fragile place. Knowledge about our place in the universe makes it more likely that we'll learn how to work together, value the planet, and survive. To create that vital knowledge, we must cultivate places where people can be free to challenge assumptions and to pursue their curiosity. Spaces where they have the specialized research tools they need and the funding and the time to think through these complexities. At our best, this is the role that universities play in our society. But for that knowledge to have impact, we also need to cultivate and celebrate translators, guides, and teachers. People like Dr. Cox, who, as a scientist, not only has the capacity to tackle the big questions, but the extraordinary ability to share answers in a way that fosters trust, excites, and inspires. I can say I just had a wonderful conversation with Dr. Cox, and we were talking about the origins of life in the universe. And I'm a lawyer, so this is, this is well outside of my field of expertise. And we just had a fascinating conversation. And I just had a little bit of insight into his extraordinary ability to take something as complex as the origin of life in the universe and explain it to a lawyer. So, I just wanted to share that with you. And as a child, Dr. Cox was inspired by another phenomenal science communicator, Carl Sagan. And today, it is Dr. Cox who is the one who is inspiring and mentoring the next generation. He is always seeking, always challenging, always leading with purpose. So we confer this honorary degree because he exemplifies the finest values of our university. He brings the drive to ask the fundamental questions and the commitment to excellence that is needed to find the answers. And above all, he brings his passion for sharing his knowledge to the great benefit of the entire world. So we are proud to welcome you, Dr. Cox, today into the University of Alberta community. Thank you.
Knowledge shall not be the concern of scholars alone, The uplifting of the whole people shall be its final goal.
They inspire us all with their brilliance, creative force, and fervent desire to make the world a better place.
I accept in the name of our poor people.
Dream your dreams. It is possible to have a new kind of world.
Those who receive an honorary degree from the University of Alberta set the highest standards of dedication and excellence for students and for society at large.
It is a good day to be you.
Remember who you are. Remember where you come from.
And while their backgrounds and fields of endeavor vary widely, all are exceptional.
Maybe it's best if I just speak from the heart.
I will remember you. Will you remember me?
We face today a clash of ignorances.
You are who make the history. You are who create the future.
U of A honorary degree recipients embody the university's vision to inspire the human spirit through outstanding achievements in learning, discovery, and citizenship in a creative community.
Your generation will be called upon to balance what is now moving quickly to a tipping point.
I think we are now in the threshold of a new beginning.
It is a spirit that is building one of the world's great universities for the public good.
It is your attitude that will sustain you. It is not what happens to you, it is what you do with it.
Go out and not simply change the world, go out and save the world. That is what I would seek you to do.
Good morning and welcome. I'm Fred West. I'm the Acting Dean of the Faculty of Science. Eminent Chancellor, on behalf of the Senate of the University of Alberta, it is my privilege to introduce Brian Cox for the honorary degree of Doctor of Science, our institution's greatest honor. Dr. Cox began his career not as a physicist, but as a rock star, playing keyboard with the band Dare, and then later with chart toppers D-Ream. During the D-Ream years, Dr. Cox obtained first-class honors degree in physics from the University of Manchester and a Master of Philosophy degree in physics. In 1997, he completed a Doctor of Philosophy degree in high-energy particle physics. Dr. Cox is now Professor of Particle Physics at the University of Manchester, the Royal Society Professor for Public Engagement in Science, and a Fellow of the Royal Society. Dr. Cox has worked on particle physics experiments at CERN and other prestigious research entities around the world. He was a member of the ATLAS experiment operating at the Large Hadron Collider in Geneva that resulted in the co-discovery of the Higgs boson in 2012. Dr. Cox is one of the world's foremost ambassadors of basic science. He's internationally renowned for his outstanding contributions in popularizing science via numerous television documentaries, radio shows, live science shows, public lectures, newspaper articles, and face-to-face interactions with school children and teachers. His popular books include Why does E equals MC squared? The Quantum Universe, and Universal, a Guide to the Universe. He's recognized and sought after advocate on the need for more funding for basic science and the dangers of global warming and junk science. Among his many acclaimed BBC documentaries, Dr. Cox presented the 5-part BBC Two series, Wonders of the World, the most successful science documentary on BBC Two for over a decade. Since 2012, Dr. Cox has entertained audiences around the world at theater and arena shows that combine stunning imagery and incredible scientific facts. His 2018 show, Brian Cox Live, filled Wembley Arena with 9,000 people, earning him the Guinness World Record for largest science show ever performed. And he told me today that that record has been exceeded by some more recent shows. James Pinfold, distinguished university professor at the University of Alberta, notes that Dr. Cox is, quote, a brilliant communicator who's been incredibly successful as a science promoter extraordinaire, helping to convey the importance and value of basic science to young people. His efforts to broadcast and publicize science has brought him numerous awards and recognitions, including International Fellow of the Explorers Club, the Michael Faraday Prize of the Royal Society, and the Institute of Physics Kelvin Prize. In 2020, he was promoted to Commander of the Order of the British Empire for services to the promotion of science. Today, we honor his contributions to advances in particle physics, including the co-discovery of the Higgs boson. We recognize his passion and unwavering commitment to popularizing science with audiences around the world. And we celebrate his unique ability to inspire joy and wonder for the natural world. Eminent Chancellor, with great pride and respect, I present Brian Cox.
Dr. Brian Cox, in recognition of outstanding contributions to advances in particle physics and the public understanding of science, I desire to confer upon you the honorary degree of Doctor of Science and to express the hope that we shall continue to be enriched by your wise counsel for many years to come. Thank you and congratulations.
Thank you very much.
An honor roll for you to sign. That'll happen after he speaks. Thank you for the directions. It's your turn.
Thank you. Thank you very much. It's, I'd just like to say thank you, Eminent Chancellor, to the Senate, to everyone at the University of Alberta. This is a tremendous honour. I thought I might just mention my connection with the university, which goes back, I think, well over 20 years now. As I mentioned, Professor Pinfold, Jim, we worked together for over a decade, actually, on an upgrade project for both LHC experiments, Atlas and CMS, and shared many happy times and a great deal of interesting research. And those detectors, which go very close to the LHC beams, are now installed around Atlas and CMS. So it's a tremendous and wonderful part of my professional life. Now, I'm working on black holes. I've changed my research interest somewhat. Someone just cheered there, I think. And I thought, just picking up on two things that were said, there are two themes I'd like to explore and mention. Black holes are interesting for many reasons, and they are, in one way, the most blue skies of blue-skied research. We've already heard that the funding for blue-skied research, just science, curiosity-led research for its own sake, is always a battle. And black holes would seem to be the most esoteric things to study. However, what we've learned, and I will be very brief because I could go on for about an hour with this, but I won't. What we've begun to learn, actually stimulated by a question that was asked as a result of work by Stephen Hawking back in the 1970s, 1974. So it's a 50-year arc of research. One of the things we've begun to ask is what happens to information that falls into black holes? Black holes would seem to be a place of no return, a place where if anything enters and falls in across the event horizon, it will go to the end of time, it will disappear, it will be removed from the universe. But Stephen Hawking and others back in the 70s and 80s noticed that that raises a profound question, which is, do these things destroy information? It sounds like a very esoteric question and almost a childlike question, a simple question with no application at all beyond curiosity. But what we've discovered in the last few years is that, first of all, we believe that if you throw something into a black hole, then the information comes out of the black hole, perhaps in the far future. But the way it comes out is fascinating. The research has become interdisciplinary. It's now not only the preserve of theoretical physics, but also quantum information science. And we're beginning to find that the way that the information seems to be encoded in the radiation that is emitted from the black hole has many similarities with challenges in quantum computing, quantum engineering, and in particular, the way that we protect quantum computers from errors, so-called quantum error correction codes. So the study of black holes has become interwoven with a very practical challenge, quantum information science. Now, what that tells us about the deep structure of nature is at the moment, I think, anybody's guess. I don't think it tells us we live in a computer simulation, necessarily, which is what I'm often asked when I mention this. Probably what we're seeing is that the deep structure of nature has as much to do with information theory as it does with mathematics. It was often said, actually, in the 20th century, if there's a God that created the universe, God was a mathematician. Going all the way back to Galileo, the book of nature is written in the language of mathematics. Perhaps what we're finding in the 21st century is that God was, in fact, a programmer and not a mathematician, but who knows? But it's interesting that there is a deep connection, it seems, between, on the one side, extremely practical research, and in fact, my PhD student who's working on this is funded by an information technology company, very practical research, and the most esoteric of research. And it's another lesson, I think the most beautiful lesson, that, well, if we want to convince the public, the governments, our societies to fund science, then we should not have to fill in forms to say, well, this is what that research is going to lead to. Who would have thought that studying black holes would lead to an intimate connection with building quantum computers in the 21st century? The other remark I'd like to make actually follows on from your remarks, actually, about the value of communicating science. We live clearly in a world that is fractious at the moment, but these challenges are not new. I became very interested in the career and research and work of Robert Oppenheimer and also Richard Feynman, two of my great heroes in physics. Oppenheimer, by the way, did a lot of the early research into black holes before the war, but is now most famous for his work on the Manhattan Project, as was Feynman. So Feynman also worked on the Manhattan Project. And in the 50s, they both became extremely concerned that the knowledge that they had delivered to our society exceeded the wisdom of our society. And they thought very deeply about a question, which is that, is there anything in this mode of thought that we have developed that nature forces us into to explore black holes or quantum mechanics or atomic structure, whatever it is? Is there anything in that mode of thought that can be translated to wider society to stop us, in their language, destroying ourselves? They were concerned in the 50s. Feynman wrote very vividly about the fact that he was very surprised to be alive in the 1950s because, as I said, he felt the knowledge of our society exceeded the wisdom of the society. And Oppenheimer actually gave a series of lectures, the BBC Reith Lectures in 1953, which unfortunately the BBC have taped over, apart from one of them, remarkably, but the transcripts still exist. And Oppenheimer said, well, there are many things, actually, that this mode of thought teaches us. But one of them is to hold complex ideas that appear at first sight to be contradictory in our heads at the same time. The example he gave came from quantum theory, just a very simple idea that a particle can be treated as a point-like object in some circumstances, but also as an extended object in other circumstances. But these two ways of looking at the particle that appear completely different are not mutually exclusive. The particle is neither one nor the other. In fact, it is in some sense a combination of the two. And he likened that to politics. He said, if you think about our politics, left and right, as Oppenheimer put it, communism or capitalism, because this was just before, by the way, he was hounded by McCarthy, months before when he wrote these lectures. He said that just in the same way that we have to hold contradictory, apparently, ideas in our heads to think about nature, so we do with a society. So centrism, which has become somewhat of a dirty word in the UK, this idea that societies are a compromise between different legitimate positions and desires, the needs of the individual, the needs of the collective. That mode of thought is forced upon us when we try to understand nature. And so there are transferable skills which science teaches us, because nature forces us to think in that way, that can be used in order to run more harmonious societies, and in his view in the 1950s, prevent us from destroying ourselves through nuclear war. Feynman felt the same thing. And I wanted to finish by reading to you a beautiful extract from an essay Feynman wrote in the 1955, I think it was, called The Value of Science. Again, trying to address this question, is there something science can teach us that we can use more widely in society? And Feynman ultimately said it's not the knowledge, actually. It's not the gadgets. It's not the things that we invent, the mobile phones or even medical technology. It's the fact that when you do science, you are more often than not, wrong. So every scientist, he says, has this intimate relationship with not only doubt, but with being shown to be wrong. Nature shows you to be wrong every day. He defines science as a satisfactory philosophy of ignorance. I think it's a beautiful definition. And he said it's that satisfactory philosophy of ignorance, the idea that we don't know everything. We don't know everything about nature. We don't know how to run a society. He said, actually, that's democracy. Democracy is the acceptance that you don't know how to do it, and so you change things every 4 or 5 years. But Feynman wrote this, and I thought I'd finish with these beautiful words. I've often tried to put them into my own words, and failed every time because Feynman was so eloquent. So I thought I'd just read to you. It's a section at the end of his essay, The Value of Science, called Our Responsibility as Scientists. And it's based on this idea that the satisfactory philosophy of ignorance is the most important transferable skill that scientists learn. So Feynman wrote this: "We are at the very beginning of time for the human race. It is not unreasonable that we grapple with problems. There are tens of thousands of years in the future. Our responsibility is to do what we can, learn what we can, improve the solutions and pass them on. It is our responsibility to leave the people of the future a free hand. In the impetuous youth of humanity, we can make grave errors that can stunt our growth for a long time. This we will do if we say we have the answers now, so young and ignorant. If we suppress all discussion, all criticism, saying this is it, we are saved, and thus doom ourselves for a long time to the chains of authority, confined to the limits of our present imagination. It's been done so many times before. It is our responsibility as scientists, knowing the great progress and great value of a satisfactory philosophy of ignorance, the great progress that is the fruit of freedom of thought, to proclaim the value of this freedom, to teach how doubt is not to be feared but welcomed and discussed, and to demand this freedom as our duty to all coming generations." Thank you very much.
Thank you so much. And now we'd ask you to sign the honor roll.
Thank you. So here.
Thank you. Thank you so much.
Thank you.
Thank you. That was wonderful. I'm sure that we'll all continue to be inspired by those words. Now we're going to enjoy a musical performance. You heard a bit at the beginning from this talented group of musicians. During the past 4 years since this ensemble's creation, the University of Alberta Undergraduate Saxophone Quartet has had the opportunity to perform challenging and diverse styles of repertoire. The ensemble contains rotating members, giving the members the opportunity to change instrumentation when a colleague graduates. The dedicated members of this ensemble show the capabilities of musicians within the Department of Music through their ability to perform challenging repertoire at a professional level. The ensemble will be performing Premier Quatuor Op. 53 by Jean-Baptiste Singelet. This piece was composed in 1857 and is an earlier work composed for the arrangement of the saxophone quartet. Over to you. Thank you. Was wonderful. Thank you very much. In closing, I would like to offer a few words of thanks. Dr. Cox, thank you once again for sharing your story and your wisdom with our university family. You are an inspiring example of leadership, service, and accomplishment. Honorary degrees are intended to honor individuals whose character and whose extraordinary achievements or service to society set a standard of excellence that merits the university's highest honor. Your latest tour, Horizons, launched on Earth Day, reminds all of us that Earth is rare and fragile, and that we have a responsibility to look after it. By sparking joy and wonder for the natural world through your public engagement, you are an excellent example of leading with purpose to make a difference. In accepting this honorary degree, you bring great honor to the University of Alberta. I also wish to thank our talented musical performers, the University of Alberta Saxophone Quartet, Danny McAfee, Kirsten Ricker, Amelia McLeod, and Lucas Rosen, as well as our national anthem vocalist Aaron Moore, an undergraduate student in the Department of Music. Thank you very much. And of course, I wish to acknowledge and thank our staff for the hard work of many people involved in planning and organizing today's ceremony, including the Office of the Registrar, the Office of the Senate, the College of Natural and Applied Sciences, the Faculty of Science, and our team at External Relations. Thank you, all of them. And I'd like to extend a final thanks to all of you, to our guests, and the audience for making today's ceremony special. I'm so glad you could join us in person. This is wonderful, and I hope you have a wonderful rest of your day. Thank you very much.